Hi guys, in this lecture we are going to discuss about the basics of probability. See, probability, probable, it comes from the word maybe. Suppose I am asking you, will it rain today? Just by seeing outside, you will be telling, it will not be rained today. There is no rain. Or, see, it's raining now. So there is a high chance. See, in 5 minutes it's going to rain because of the heavy cloud. See, my teacher, there are some clouds. I don't know exactly whether it's going to rain or not rain. So, if there is an oscillation, we call it as probability. That is, if the word maybe rises, then we call it as a probability. So, whenever we are saying with indefiniteness, we call it as a probability. Now we are going to assess that qualitative one in terms of the qualitative items. The basic example based on those are usually the coins, dice. So in this lecture we are going to discuss what will happen and what are the probabilities, the cases we can find while tossing one coin once, two coins once, three coins once, one die once, two dice once, three dice once. Let's go ahead with the lecture. See, since we are talking about the probability, that probability of the event A, P of A, that lies between 0 to 1. The probability of the impossible event is 0 and the probability of the sure event is 1. If it lies in between, we call that as the probability of the event A. So the probability of the sure event is 1. Now, what is A and what is S? See, S what we call as the sample space and A what we call as the event. So what is the event and what is the sample space? Suppose this is your sample space and this will be your event A. The sample space is the set of all possibilities and event is the one which you want. That is the required outcome, your favorable event you want. Okay. Suppose we are talking about Al Musanna College of Technology and that is a sample space and the BTech, the baccalaureate or the engineering department is the event. If you are talking about the engineering event, the probability and statistics course is the event. If you are talking about the probability course, consider that as a sample space and choosing the name starting with the S is the event. If you are collecting all the names starting with the S, if we consider that as a sample space and choosing a particular student is the event. So the total possible outcome is called the sample space. The favorable event which you want is called the event simply. Okay, let's go ahead with the simple problems and then you can understand the rest. There is a rule behind this. Probability of the event A is equal number of items in A, number of items in S. Simply say the number of items in your event divided by the total number of items. Consider your marks. What is your mark? For example, 15 out of 20. Out of means the total. 15 is your mark. So it is 15 divided 20. We can call it as a probability. That probability is less than 1. It's greater than 0. So your probability cannot be negative. Your probability cannot be greater than 1. One coin we are going to discuss now. One coin singular. So, what are the possible outcomes? The sample space. Suppose I am tossing a coin like this. What will happen? Either it may be the upside or it may be the downside. That is either head or it may be a tail. So there are two possibilities, head and tail. We will be getting as the outcome. You are very mischievous. See, in this outcome we are considering only head and tail. While tossing, if your coin comes like this, don't take that as an outcome, just leave that as it is. It's not an outcome. Okay. So the number of items in the sample space is 1 plus 1, that is 2. So what is the probability of getting a head? 1. What is the probability of getting a tail? 1. See boys, the probability is divided by the total number of items. So this 1 is the number of items over here. So you have to divide by the sample space, n of s. The n of s is 2. So after dividing by 2 only, it will be converted to probability. And please remember that the probability is always less than 1. So it cannot be when? It cannot be 2. It cannot be 3. It should be divided by the total. Okay. What is the probability of not getting my head? I don't want head. What is the probability of not getting head? See the notation what I am using? Bar. It can be a bar, or it can be a dash, or it can be a C, what we call as the complement. See, so this is the event, this is a complement, or a dash, or a bar. The probability of not happening A. Okay, P of HC is equal to, this is, the total is 1. See, this is the total. It starts from 0 to 1. This is the probability of occurrence of head, that is 1 divided by 2. I don't want remaining. How can we find? Very good. The total minus this item. So 1 minus 1 by 2 is equal 1 by 2. So now we are getting a new rule for probability. The probability of the not occurrence of A is equal 1 minus P of A. Okay. Let's go for 2 coins. What is the sample space for 2 coins? Can you say, please? The sample space for 2 coins? See, we are taking, first I am taking 1 coin, above that another coin, I am tossing this. While tossing this, what may be the outcomes? What may be your result? Very good. First coin is head, second coin is head. First, please, here while writing, you please go in the order. First finish your heads and then go for the tails. So it is head and tail. Now go for tails. It is tail, head and tail, tail. This is your sample space. Good. So what is n of s? 4. What is the probability of getting 2 heads? What is the probability of getting 2 heads? How many 2 heads is there? 1. So it is 1 divided by 4. Probability of getting 1 head. How many 1 head is there? Here it is 1 head, here it is 1 head. So totally 2 numbers. So it is 2 divided by 4. What is the probability of not getting any head? Not getting any heads. I don't want head. So I need only tail. What is it? Where is the tail? Here. Only tail. No, only tail I need. Only tail. I don't want head. Very good. That is 1. Only 1. So it is 1 divided by 4. This is the case we are discussing for 1 coin and 2 coin. And see, for 1 coin, it is 2. How many number of items are there? 2. For 2 coins, there are 4. How many number of items? 4. there is a simple trick behind it here. This can be written as 2 power 1. That is 2 power the number of coins I am tossing. Because my outcome is 2. Head and tail. And the number of coin I am going to toss is 1. So it is 2 power 1. So I will be getting exactly 2 outcomes. And here I am going to toss 2 coins. See, so while tossing 1 coin, my outcome is 2. The number of outcomes is 2. I am going to toss 2 coins. So it is 2 power 2. So this is 2 power 2. I will be getting 4 outcomes totally. The number of outcomes is 4. Suppose I am tossing 3 coins. I am tossing 3 coins. What may be the number of outcome? N of S is equal. What may be that? Very good, very good, very good. Excellent. 2 power 3. Because for 1 coin it is 2 and I am tossing 3 coins. So it is 2 power 3. Totally I will be getting 8. Now the question is for you. What are the elements in my sample space while tossing 3 coins once? S. I want to write my S. What may be the items over here? How to write? First one is correct. H, H, H. Okay. Okay. This one is also okay. T, T, T. It is okay. The next. Try. Good. You can try. Try. Practice makes a man perfect. Yes. The best way to do the mathematics is to do the mathematics. H, H, T. Yes, T, H, H. Yes, T, T, H. We are struggling a little bit, right? We have to think a little more in order to give the answer. So, see, even in my 3 coins, I start to struggle for writing my sample space. What will happen if it is for 4 coins? 5 coins? And we have to generate some computer programs for that. That may be a better way. Even for computer programs, in order to access that easily, in order to get our solutions easily, we have to give some tricks. The easiest way. That's what we are going to do now. Let me write the sample space of 1 coin. What is the sample space? My sample space S is head and tail. Let me write the sample space of 2 coins. What is my S? See how I am going to write it. First it is head and tail. This is for 1 coin. Head and tail. This is for another coin. That is I am writing only my first coin. So the second coin is going to associate with my first coin. So here this can associated with head and this can associated with the tail. H, H, T, H, H, T, 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 which will be my sample space here, and totally N of S is equal to 4, the 2 power 2, everything has been satisfied. Let's check the same whether it is applicable for 3 coins. So now it is for 3 coins. For 3 coins, write the sample space of 2 coins because 2 plus 1 is 3. Already we have 2. Another coin going to associate it with these 2 coins. So write the sample space of the 2 coins. TH, TT, HH, HT, TH, TT. This will be my S. So now what we have to do? Correct. Very good. So just join H backside. And just join T second. Put commas in order to separate. Totally how many we have? 4 and 4. Totally N of S is 8. Let us do the same for your computer programming. You will be getting your solution in order to generate the sample space of 10 coins or 50 coins. Okay. So the sample space of the 3 coins is HHH from and TTT to the end. And the number of items is 8. Okay. Now let's consider the dice we are going to discuss. So now it is one die. First, what is a die? A die is a cubic form in which it has 6 faces. In every face there will be the numbers 1, 2, 3, 4, 5, 6 like that. You know that? Then no issues, just leave that as it is. If you know, that's really happy for me because my work has been simplified, right? So what is the sample space? Now it is easy for me. 4, 5, 6. So n of s is equal to 6. What is the probability of getting odd number? Odd numbers. Probability of getting even numbers. Probability of getting prime numbers. Probability of getting a number 4. A number 4. Probability of getting a number which is greater than 4. Probability of getting a number which is less than or equal to 4. Probability of getting a number greater than 4 and that is a number, okay? A number greater than 4 and less than 3. Probability of getting a number which is less than 7. These are the questions we are going to answer right now. Okay, first one. What is the probability of getting the odd numbers? Yes, please. How many odd numbers are there first? How many odd numbers are there in your sample space? You have to consider only your sample space. Don't go beyond 6 because in your sample space you have till 6 only. So you have here one is 1, 3, 5, right? Okay, how many elements are there? 3. So it is 3 divided by the total number of items is 6. What is for even numbers? Very good, excellent, easy, right? It's very easy. Don't think that probability is difficult. So this is 3 divided by 6. Prime numbers, what's a prime number? What's a prime number actually? A number which is divisible by 1 and itself alone is called a prime number. Say for example, consider 2. 2 is equal 2 into 1 and 1 into 2. What is 3? 3 into 1 and 1 into 3. What is 4? 1 into 4, 4 into 1 and 2 into 2. It's not a prime number. And 5 is equal 1 into 5, 5 into 1. 6 is equal 1 into 6, 6 into 1, 3 into 2, 2 into 3. It's not a prime number. Like this. And you can generate. And how many prime numbers are there right now? 1. 1 is not a prime number. 1 is not a prime number. The prime number will start from 2 onwards. Yes, now. 2, 3 and 5. Good, 3. So it is 3 divided by 6. Good. And number 4, the easy one. No. 4 divided by 6 is not the correct answer because, see, you have to count the number of items. You have to count the number of items. How many 4 is there? 1. Right? That is your favorable event is to get 4. That is one number. So this is 1 divided by 4. Please don't write this number divided by 6. I'm sorry. This is 1 divided by 6. Please don't write 4 divided by 6. That is only one number, right? A number greater than 4. How many numbers are greater than 4 here? 5 and 6, right? Good. 2 numbers. Wow, very good. 2 numbers. So it is 2 divided by 6. A number less than or equal to 4. How many numbers less than or equal to 4? Very good. Less than or equal to. Remember that equal to also. 1, 2, 3 and 4 also. So how many numbers totally? 4 numbers. Very good. So this is 4 divided by 6. What? Simplification. That you can simplify. If you want, you just cancel this and you will here you will be getting 1 divided by 3, and here you will be getting 1 divided by 2, and this is 2 by 3, which is equal to, you can use your decimal also. A number greater than 4 and less than 3. How many numbers are there like this? Greater than 4. Greater than 4 means 5 into 6. And also that number should be less than 3. Less than 3 is 1, 2. There is no number in common. There is no such a number. And hence there is 0 numbers. Which means that this is an impossible event. You will not get such an answer. This is an impossible event. And a number less than 7. How many numbers are there? Less than 7? Absolutely all the numbers, right? All the numbers are less than 7 only. So all the 6 numbers are less than 7. So, very good. 6 divided by 6, that is 1. Where this 1 is a sure event. Definitely it will happen. If you choose any number, that will be less than 7. So there are 100% chance of getting such a number. In a try. Okay. Now let's go for 2 dice. Let's go for 2 dice. What is the sample space over here? Sample space. See, you just remember the same as what we have discussed in the coin. In the coin, we have discussed today. What is it? First it is head and the tail in the first coin, and join another one in the second coin. So here also do the same. First it is 1 die. In 1 die you will be getting 1 to 6. You will be having another die. You just associate that with this, and hence it is 1, and for the next die there are 6 numbers. So with this one, the 6 possible numbers of second die may happen. That's what you are going to write as a sample space. So now 1 1 1 2 1 3 1 4 1 5 1 6 2 2 2 3 2 4 2 5 2 6 3 1 3 2 3 3 3 4 3 5 3 6 4 1 4 2 4 3 4 4 4 5 4 6 5 1 5 2 5 3 5 4 5 5 5 6 6 1 6 2 6 3 6 4 6 5 6 6. How many number of items are there? 36. There are 6, and here it is 6. 6 into 6, that is 36. Let's try to answer for our questions. Shall we? Yes. The first one, probability of getting doubles. The second one, probability of getting 3 in the first die. Probability of getting 6 in the second die. The fourth one, probability of getting 3 in first die and 4 in second die. Let me change this wrong numerals. So it's still 4, right? Let me take it as 5 for easiness. Okay, 4 in the first die. Sum probability of getting, the sum is odd. Probability of getting sum is even. 7. Probability of getting the sum is a prime. And there are many more questions over here. Let's discuss these 7 questions. Probability of getting a doubles. What is a double? Good. Both the numbers are same. How many same numbers are there? Very good. 1 1 2 2 3 3 4 4 5 5 6, 6. There are 6 numbers. So totally it is 6. What is the total number of outcomes? 36. 6 divide 36. 3 in the first die. How many items are there? 3 in the first die. Consider only first die. Which is first die? This is in the first die and this is in the second die. 3 in the first die. Very good. 1, 2, 3, 4, 5, 6. So totally 6. 6 in the second die. What is the answer? Correct. Good. We'll be getting the same answer, right? So this is 6 divide 36. Check. 6 in the second die. In the second die, 6. 1, 2, 3, 4, 5, 6. 3 in the first die and 4 in the second die. 3 in the first die and 4 in the second die. How many items are there? How many items can be? Check. 3 in the first die. 3 in the first die. And 4 in the second die. 4 in the second die. There is only one item. 3, 4. So, there is only one favorable event, and hence this is 1 divided by 36. The sum is odd. The sum is odd, which means that if you add these two numbers, the answer should be odd. Okay, now what I am going to do, see the sequence of my question, odd, even and prime. So better add all the numbers. See, 1 plus 1, 2. So 2, 1 plus 2, 3, 1 plus 3, 4, 5, 6, 1 plus 6, 7, like this, okay? And I am going to do the same for the second. 2, 1, 3. So let me start from 3, 4, 5, 6, 7, 8. Go for the next. From 4 or 3, that is 4, 5, 6, 7, 8, 9. Go for the next. 5, 6, 7, 8, 9, 10. Go for the next. 6, 7, 8, 9, 10, 11. Go for the next. 7, 8, 9, 10, 11, 12. With this is finished, right? 1, 2, 3, 4, 5, 6. We have only 6 rows. So, it's finished. Okay. How many odd numbers are there? It's nothing but the same question, right? The probability of getting the sum is odd is equal to how many odd numbers are there. Let's count how many odd numbers are there. 1, 2, 3, 4. Right? Next. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So this is 18 divided by 36. So obviously how many even numbers are there? The same answer, right? So it is 18 divided by 36. Now, the sum is a prime number. How many prime numbers are there? How many prime numbers? 2 is a prime number. 3 is a prime number. 4 is not a prime. 6 is not a prime. 4 is not a prime. No 6, no 8, no 4, no 6, no 8, no 9, no 6, no 8, no 9, no 10, and no 6, no 8s, no 9s, no 10s, no 12. How many numbers are there now totally? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Totally 15 numbers. So the answer is 15 divided by 36. Now, let me go ahead with only the last one question. Let me add this as a 8th one. What is the probability that getting a sum is a composite number? What is a composite number? A number which is not a prime is called a composite. A number which is not a prime is called a composite. So what is the answer here? I deleted everything. You have the answer. A number which is not a prime. The total probability is 1. So this is 1 minus probability of getting a prime. So 1 minus 15 divided by 36. How many we left with? 21, right? So this is 21 divided by 36 is the probability of getting the sum is a composite number. A number for whose sum is a composite number. Okay. Hope you understand this lecture. In this lecture we have discussed the basic of probability with 1 coin, 2 coin, 1 dice, 2 dice. We will be meeting soon in the next lecture with some other problems, with some other concepts. Till then, meet you, see you, and bye bye.